Organics Removal by Iris Nunez, Mauricio Ornelas Zamores, and Tong-Sing Hu. Our project is on organics removal, so we will be focusing on the circled part of the wastewater treatment process. This includes different types of treatment not shown in this image, using suspended growth or attached growth. The purpose of wastewater treatment is to remove suspended solids, pathogens, and nutrients to not cause problems like what we saw with John Snow.
The typical contaminants found in wastewater include floating, suspended, dissolved materials, and dissolved gases. For organics removal of wastewater, the primary goal is to remove most of the biodegradable organics. It can be achieved through a biological process by the activated sludge containing aerobic bacteria, and a physical process by settling of the sludge. This process is important because excessive discharge of organic matters and nutrients to the water bodies can cause excessive growth of algae, which deplete the dissolved oxygen, choking water animals and plants. Some toxic organic compounds can bioaccumulate in the food chain and go into our bodies. So, the following are the associated parameter measurements: biochemical oxygen demand and suspended solids. BOD is the amount of oxygen used in the metabolism of biodegradable organics. It is used as an indicator of organic pollution of the water. The BOD of a water sample is determined by placing water sample or dilutions of the water sample in 300 milliliters bottles with glass stoppers, incubating at 20 degrees Celsius and measuring the change in dissolved oxygen concentration with time. BOD5 measures the oxygen consumed in a 5-day period. BODU, which is ultimate biochemical oxygen demand, is the total amount of oxygen consumed when the biochemical reaction reaches to the end. BOD5 is more used internationally as a standard reference value of organic pollution. For suspended solids, all contaminants of water contribute to the solid's load, except for the dissolved gases. Total suspended solids are solids in water that can be trapped by a membrane filter with a pore size of about 1.2 micrometers. Volatile suspended solids are suspended solids that volatilize at a temperature of 550 degrees Celsius. Usually, volatile solids are organic. So by EPA, the secondary effluent need to have both BOD5 and suspended solids lower than 30 mg per liter or 15% lower than the influent. There are some important design considerations for organic removal of wastewater treatment. There are two common conventional methods used to remove up to 90% of the organic matters in the wastewater. One is suspended growth process and another is attached growth process. In suspended growth process, the microbial growth is suspended in an aerated water mixture. Activated sludge process is an example of suspended growth. In attached growth process, the microbial growth occurs on the surface of stone or plastic media. Wastewater passes the media with injected air. Trickling filters and rotating biological contactor are commonly used attached growth process units. These two options will be explained and compared later. The necessary inputs are mostly oxygen and activated sludge. Oxygen can be introduced by pumping compressed air into the water to support the reaction listed on the slide. And activated sludge should be recycled to maintain the biological process. The mean cell residence time, also known as the sludge age, is defined as the average time the microbial culture stays in the system. It is usually designed to be 3 to 10 days and controlled by the wasting rate of the sludge. Steady-state mass balance on suspended solids is maintained. In order to keep the microbial sensitivities, minimum organic concentration is required. When the concentration decreases below the minimum value, the growth rate becomes negative, making the process less efficient. The growth rate can be estimated as the rate of production of volatile suspended solids.
These two common alternatives use organisms that grow in suspension. The bacteria used in all of the treatments use the organic pollutants to grow and transform it to energy, water, CO2, and new cell material. For the activated aerated sludge basin, the aerated sludge process typically includes a physical pre-treatment unit, the aerated tank, and a post-settling unit. From there, the active sludge is recirculated to the aerated tank for further treatment. Once the wastewater has received sufficient treatment, excess mixed liquor is discharged into settling tanks, and from there, the active sludge is recirculated to the aerated tank for further treatment before discharge. This treatment is very good for the removal of organics and suspended solids. For stabilization ponds, the stabilization pond systems operate in 3 stages, with the anaerobic, facultative, and aerobic ponds. The first stage, anaerobic ponds, achieve a high volumetric rate of removal by decomposition. From there, the effluent from the anaerobic ponds will overflow into the secondary facultative ponds, which make up the second stage of biological treatment. Following primary or secondary facultative ponds, if further pathogen reduction is necessary, aerobic maturation ponds will be introduced to provide tertiary treatment. These two common alternatives use organisms that grow as slimes on surfaces. For the trickling filter, the treatment biodegrades organic matter by using microorganisms that are added to an inert filter material such as a fixed bed of rock, slag, plastic filter media, sand, gravel, and/or a variety of plastic and other synthetic materials. Over this material, wastewater trickles downward to form a microbial slime layer covering the media bed. The treated water is then collected at the bottom. This treatment is great for removal of organic solids. For the rotating biological contactors, they are created with a disc design partially submerged, with ridges in order for large amounts of biofilm to attach, which means that there is a large amount of biological mass present to degrade the pollutants. As the biofilm passes through the wastewater when rotating, nutrients and organic pollutants are taken up, efficiently treating the water. The higher contact time in rotating biological contactors due to its rotation allows up to 8 to 10 times higher levels of treatment than in trickling filters. This chart summarizes the advantages and disadvantages of the different treatments, also including for what instances they are most applicable. Comparing them, we can see that most of the treatments have high costs. We can also note that there are differences in space requirement both in length and in depth. They all have different aspects of treatment that they excel at, and all of them can have odor problems.
Now we'll be looking at regulations and rules that play a factor in wastewater treatment, and with the most important being the Clean Water Act, which was passed on October 18, 1972. And the main thing it consists of is that it established a basic structure for regulating pollutant discharges into waters of the United States. It also gave the EPA the authority to implement pollution control programs such as setting wastewater standards for industry. It also maintained existing requirements to set water quality standards for all contaminants in surface waters. It funded the construction of sewage treatment plants under the Construction Grants Program, and it recognized the need for planning to address critical problems posed by non-point source pollution. Also have to keep in mind that the CWA does not directly address groundwater contamination. Continuing with the Clean Water Act, it was established that it was unlawful for any person to discharge any pollutant from a point source into navigable waters unless a permit was obtained under its provisions. The EPA's National Pollutant Discharge Elimination System permit program controls discharges. Point sources are discrete conveyances such as pipes or man-made dishes. Individual homes that are connected to a municipal system such as septic system or do not have a surface discharge do not need a permit. However, industrial, municipal, and other facilities must obtain permits if their discharges go directly to surface waters. We will now be looking at revisions that were made for the Clean Water Act in 1987. These revisions include that they streamlined the municipal construction grant process, improving the capabilities of treatment plants built under the program. They also phased out the construction grants program, replacing with the State Water Pollution Control Revolving Fund, which is also known as the Clean Water State Revolving Fund. This new funding strategy addressed water quality needs by building on EPA-state partnerships. And the last revision that was made is measures to address sources of pollution by directing states to develop and implement management programs targeting their major non-pollutant sources. Federal grants covering up to 60% of the program costs, but were also authorized to assist states in tackling their difficult pollution. Now we'll be looking at low-energy alternatives within wastewater treatment, with the first being biosand filters. It was developed by Dr. David Mans in the 1990s at University of Calgary, Canada. It is a point-of-use water treatment system adapted for traditional slow sand filters. It reduces discoloration, odor, and a pleasant taste. It can also remove heavy metals, turbidity, bacteria, viruses, and protozoa. Biosand filters remove pathogens suspended cells from water using biological and physical processes that take place in a sand column covered with a biofilm, which you could take up on the photo on the right. There are 4 different processes within the biosand filter, with the first being mechanical trapping. It suspends the solids and pathogens that are trapped in spaces between the sand grains. Then there's predation, where pathogens are consumed by microorganisms in the biolayer. And then there's absorption, pathogens absorb into each other into suspended solids in water and sand grains. And then there's natural death, where pathogens finish their life cycles or die because there's not enough food or oxygen. Continuing biosand filters, there are 3 different types: concrete filters, plastic filters, and stainless steel filters. But concrete filters are the most widespread type of biosand filter because it is low cost, wide availability, and the ability to be constructed on site. Continuing, studies have shown a correlation between use of biosand filters and a decrease in the occurrence of diarrhea. And because of their effectiveness, ease of use, and being inexpensive, biosand filters are often used in developing countries. Here's a list of advantages and disadvantages of using a biosand filter. I'll just run over some quick ones. Some advantages will be high removal of pathogens, and the removal of turbidity, color, odor, and iron, and also relatively high flow rates can be achieved over 30 liters per hour, and it has a long life. Some disadvantages are biological layers take 20 to 30 days to develop maturity. There's a low rate of virus inactivation. It requires the filter to be used on a regular basis, and it cannot remove dissolved compounds. The second low-cost alternative we'll be looking at is solar distillation, which is the use of solar energy to evaporate water and collect its condensate within the same closed system. It can also be defined as measures to separate and extract clean water by vaporization. This is useful to turn seawater, brackish, or even contaminated water into clean water for safer drinking. This all relies on a simple procedure where an influent solution enters the system and the more volatile solvents leaving the influent, leaving behind a salty solute behind. This system differs from other methods, such as reverse osmosis or sipping boiling water, due to its use of free energy, while these other systems tend to be more energy intensive. Now, a solar still can actually be pretty cheap in simple piece of shaped plastic or glass, or they can be as highly designed devices. But to work, it all allows sunlight to shine through a clear panel onto the impure water. Continuing with solar distillation, there are 2 categories of typical single-slope basin still, active or passive. They are classified by the methods it still uses to acquire the energy to drive the evaporation of the water. Passive solar stills are more conventional and have been the only ones discussed up to this point. A conventional solar still relies solely on the sun to distill water, while an active solar still can obtain waste heat from a myriad of sources, but requires a good insulator because it reduces thermal losses and prolongs the evaporation process even into the night. On the right, you can see there are certain examples from each type of method, with the top right diagram showing a single effect basin and on the bottom showing a more solar heater. Due to time, pause the video and give a quick skim of our summary and conclusion that pretty much covers everything we have in our presentation in a more concise form. So now we have a couple of quiz questions for you guys, with number 1 being, what is the purpose of wastewater treatment? Number 2, what is one advantage and one disadvantage to using biosand filters for water treatment? Number 3, what was one of the revisions made in 1987 for the CWA? Number 4, what is the importance of removing primary contaminant removal treatment? And number 5, what is BOD test?